Before a collision, a 25 kilogram object is moving at 12 meters per second. Find the impulse that acted on the object if, after the collision, it moves at positive 8 meters per second or B, negative 8 meters per second. So let's solve this. Well, let's do given, find, and solve. So given, I've got an object, and its mass is 25 kilograms. And we know that its initial velocity is 12 meters per second. I'm not going to bother with the negative. I mean with the positive here. And what we want to know is we want to find the impulse. Now you can write that as sort of like impulse. We want to know force times time if V final is equal to 8 meters per second. And then for part B, we want to know the impulse if V final is negative 8 meters per second. And so let's solve this. Well, we know that the impulse is equal to the change in momentum of the object. So all we have to do is figure that out. So for part A, the impulse is equal to the change in momentum. Well, what is that? That's the mass times the change in velocity. But that is the mass times V final minus V initial. Okay, so delta P then is equal to well, we know what the mass is. Now V final is given to be 8 meters per second. Oops. 8 meters per second minus the initial velocity, which was 12 meters per second. Now 8 minus 12 is negative 4. Negative 4 times 25 is 100, negative 100. Now this is kilogram meters per second, but it's asking for impulse. Now if you put a box around this, I'm going to give it to you. The impulse momentum theorem says the impulse is equal to the change in momentum. But just to be complete, I'm going to say this. F times delta T, the impulse, is equal to negative 100.
You're wrong. Can't see it.
Oh, thank you. Newton seconds. Now, which one of these is? That doesn't mean this is wrong. I'm just putting it in the units that we use for impulse, which are newtons times seconds. Force times time, newtons times seconds. Now, remember that a newton is a kilogram meter per second squared. So if I multiply a newton times a second, the second cancels the second. I do indeed get kilogram meters per second. That is, they are equivalent units. For part B, we're going to do the same thing, but now the change in momentum is equal to 25 kilograms times the V final is negative 8 meters per second minus the initial velocity was, 12 meters per second. That's 20, or negative 20. Negative 20 times 25 is negative 500. So the force times time would be equal to negative 500 newtons times seconds, if you chose to express the units that way. You didn't have to go through the whole algebraic derivation again for part B. You could just use the results that you have here, down here directly. And notice that here we didn't change the velocity very much. We just went from 12 to 8, so we slowed down by 4. And we didn't need nearly as much impulse, because here we went from positive 12 to negative 8. That's a change of negative 20 meters per second. So you have to apply a much greater impulse to get that much greater change in velocity. Okay, so Here's the whole thing. Any questions? That is all.